As Venus orbits the Sun, it rotates in the opposite direction with respect to the other planets, and extremely slowly, just once in 243 Earth days. This is even longer than a Venusian year. Unlike the slow rotation of the planet, the top of the Venusian atmosphere whips around in just 4 days. Most of the atmosphere around Venus consists of carbon dioxide. Incredibly, Venus and Earth have about the same amount of carbon dioxide. On Earth, it is locked up in the crust in the form of carbonates. On Venus, it mostly exists as gas. Sulfur dioxide is also present in the atmosphere, and through chemical reactions with water vapor, form sulfuric acid droplets. These droplets develop into complex, thick, swirling clouds that form noxious fog and acid rain on the surface of Venus. The dense atmosphere exerts a pressure that is 90 times greater than the atmospheric pressure on Earth. With no protective magnetic field around the planet, the solar wind strips gas from the atmosphere of Venus out into space. This has a huge effect on the climate of the planet. Venus is the hottest planet in the solar system, with a surface temperature of over 700 Kelvin, despite only a small fraction of the light it receives from the Sun reaching the surface. The large amount of carbon dioxide and other gases trap enough energy to increase the temperature dramatically, causing an enhanced greenhouse effect. Such a high surface temperature led scientists to quickly dismiss ideas of present-day oceans of liquid water and life on Venus. The age of a planet's surface is generally determined by the number of craters present. In the case of Venus, only the largest rocks would be able to survive the journey through the thick atmosphere. Therefore, Venus has very few craters on its surface, and none that are older than about 500 million years. At some point in the past, over a short geological time period, the entire planet was flooded with lava.
The first spacecraft to visit Venus and Mars completely changed humankind's view of Earth's planetary neighbors. Scientists now realize their similarities as well as their differences to Earth. Greater knowledge of Mars and Venus has spurred continued exploration with even more advanced spacecraft. Exploring a hostile world like Venus is challenging. Spacecraft that have landed on the surface have quickly succumbed to the intense heat, extreme atmospheric pressure, and burning acid rain. Attempting to probe the atmosphere in visible wavelengths alone is futile, as the clouds cannot be penetrated and show no features or markings. Therefore, other wavelengths of light must be used. In 2005, the European Space Agency launched its first mission to explore Venus, and the first to go there for more than 10 years. Venus Express made a 5-month journey from Earth to study the planet from orbit. This spacecraft is packed with a suite of instruments to study the Venusian atmosphere and near-space environment at radio, visible, and infrared wavelengths, performing spectroscopy and measuring energetic particles. Data from Venus Express allows scientists to study how the workings of the atmospheric loss to space, and the greenhouse effect all act together to produce a climate so different from Earth. Venus Express primarily examines the planet's atmosphere. However, the atmosphere is so dense and therefore closely associated with the surface that studying it will provide clues to the nature of the planet as a whole.
The thermal infrared camera on board Venus Express has peered into the thick atmosphere and allowed scientists for the first time to map the wind, speed, in 3 dimensions. To achieve this, the thermal camera tracked clouds at 3 different levels in the atmosphere, including those just 50 kilometers above the surface, for long periods of time. This provides enough data to allow scientists to start piecing together a picture of the atmospheric phenomena. Data from the onboard spectrometers have shown that the amount of toxic sulfur dioxide varied considerably over just a few days. Sulfur dioxide is not thought to stay for very long, and so it must be being released into the Venusian atmosphere. Otherwise, it would disappear. But how this is occurring or what mechanism is releasing this gas is not known. It is likely to be released during volcanic eruptions, but there is as yet no evidence of this process taking place. Water vapor is present in the atmosphere of Venus, but in a very low quantity. Venus Express detected the way in which the atmosphere of the planet is being lost to space. This has provided vital clues as to what happened to the water on Venus. High in the atmosphere, water is broken down into its constituent parts, which are then stripped from the atmosphere by the solar wind, meaning that Venus is still losing water. Measuring the amount that the planet is losing from the atmosphere and calculating backwards over time indicates that Venus may once have had the same amount of water as the Earth does today. Venus Express data confirmed that the Venusian atmosphere generates its own lightning. This was an important discovery as electrical discharge breaks molecules into fragments, enabling chemical processes to take place that would not otherwise be possible. Lightning also occurs on Earth, Jupiter, and Saturn. However, on Venus, it is unique, as it is the only type known to be associated with clouds of sulfuric acid.
Since its launch, Venus Express has revealed new aspects of the planet and will continue to peer into and through the Venusian atmosphere to piece together answers to as yet unsolved questions. Are volcanic eruptions responsible for topping up the levels of sulfur dioxide in the atmosphere? Will Venus Express detect a volcano erupting? Venus seems to have been more Earth-like in the past and to have had large quantities of water. What happened to cause its climate to change so radically, and when? What will happen to the Venusian atmosphere in the future? And how will the climate evolve?
Biological activity is something that, of course, is a very hot topic, and we can imagine places in the atmosphere of Venus where, for example, we have these ultraviolet absorbers. There we have a condition which are not too far from the Earth's conditions in terms of pressure and temperature. And if something like that is going on, this is the right place. Fairly recently, in geological terms, about 500 million years ago, there was quite a dramatic global resurfacing of material coming up from below and filling out all the old craters and wiping out all history and creating a completely fresh new surface. This is not exactly known why it was, but we have the record from this.
Your dream would be to find a volcano?
That wouldn't be very nice. To see an active volcano with all what comes with it, it would be a great thing. We see these parts above the clouds. It is some material, some sort of microscopic material that absorbs these ultraviolet lights. We can see great patterns if you look in ultraviolet filters. But really what it is, we really don't know this, and we will try to find that out. And this is, of course, an environment on the planet where the parameters like the pressure and the temperature are the most Earth-like. So if there would be anything like microscopic life, this would be in this place. But this is really something we have to study a bit further. I think that we want to prove that there is volcanism on the surface. This is something which is suspected, because we know that the surface has changed within the last, say, 500–600 million years, which on a geological time scale is a very short time, considering that the planet is existing for maybe 4.5 billion years. We want to see why has the surface changed so recently? There must be volcanism, but we don't know that. We want to prove that, and we can do that with these instruments.
But to such an extent that volcanoes could resurface the entire planet?
The process on the resurfacing is slightly different on Venus compared to the Earth. On Earth we have what we call the plate tectonics. This is several large plates on the upper surface of the Earth that are moving with respect to each other. And on the borders between these lines we get volcanism and earthquakes. On Venus we don't have that. It seems like we have just one big plate covering the whole planet, and when it comes to the point that there is an instability somewhere in below the surface, this has an effect on the global scale. So we believe that this resurfacing has taken place in a reasonably short time, and in that way reshaped the whole upper surface of the planet. In the 50s and in the earlier days, It was in general believed that Venus was quite similar to the Earth, and there was a dense atmosphere that was known, but it was also thought that there was a lot of water vapor in the atmosphere, and the cloud layer was just like the Earth's cloud layer. So we had some similar situation like in the jungle. So there were being pictures drawn in those days of jungle landscapes and even creatures living down on the surface, very much similar to on the Earth. By radio astronomy observations, that detected that it seemed like in the radio frequency range, the radiation from the planet indicated that the temperature was much, much higher than on the Earth. Many people didn't believe that, they didn't trust those measurements. But when the mariner made the flyby of Venus, they had real reliable instruments that showed that the initial measurements were indeed right and the temperature was very, very high.
After Russian and American missions, ESA decided to join in the exploration of Venus. So Venus Express was launched in 2005. A Soyuz rocket put the 1,250-kilo probe into orbit, the start of its long journey to Venus. It would arrive 153 days later.
In the beginning, we did a few very, very elliptical orbits, taking us very far from the planet, so we could do long sequences of observations from long distance. And that was very useful to see and track how the motion of the weather patterns were moving. And then we were finally, after a few weeks, coming into our final orbit. Since then, we have done a large number of different measurements with the 7 instruments we have on board. They are covering spectral ranges from the ultraviolet into the visible range, and a bit into the infrared range. And the infrared observations are particularly interesting because we can probe through the dense atmosphere and through the cloud layer, and even at 1 micron wavelength we can see all the way down to the surface, in fact.
After 6 years of intensive observation, what more do we know about Venus's mysteries? Well, with a surface temperature of around 400 degrees, the least we can say is it's a hostile environment. But there's more.
Venus takes 220 days to go around the Sun. It's a bit closer. But the day is in the opposite direction to the Earth's rotation, and it takes 240 days, but in the opposite direction. We don't understand this at all. It's completely unlike the other planets in the solar system. It could be that it's some a collision that happened early on in the life of Venus. It could be some other effect due to the very dense atmosphere and interactions with the sun and so on. We simply don't know.
Ultraviolet rays penetrated the thick, mostly carbon dioxide and sulfur atmosphere, stripping away the hydrogen. This left a waterless planet subjected to strange, violent winds.
On the surface of Venus, the wind speed is rather low. It's a rather gentle wind. But high up in the clouds, about 100 kilometers from the surface, the wind speeds are very, very high. The wind is traveling at 300 kilometers an hour, and it travels around Venus every 4 to 5 days. So that's one of the things we don't understand, why at the surface the winds are very gentle, and high up the winds are very, very fast.
Venus Express revealed a gently sloped landscape with vast volcanic-looking plains. It's thought the planet's internal heat escapes through lava flows, and a number of volcanoes have been found.
We know very little about the nucleus of Venus, whether there's like the Earth, we have a core and then a mantle. We don't know whether that's the case on Venus yet. The Earth's surface is constantly renewed by plate tectonics. The Earth's surface is about a quarter of the age of Venus's surface. Venus doesn't suffer from plate tectonics. And again, that's an interesting difference which we don't understand between the two planets.
Venus is a planet that guards its secrets well. We still know little about its surface or atmosphere, but that mystery still tugs us heavenwards to explore and discover.
We're discovering new things all the time. For example, one of the very interesting discoveries of Venus was a huge vortex, a huge cloud at one of the poles of Venus that in some ways looks very similar to a hurricane on the Earth. But this is a long-standing event that's there all the time, and we don't understand how it's formed, why it's there, and how it will evolve.
Venus Express was designed to run for 2 Venusian days, or around 500 Earth days, but has proved so reliable, the satellite's mission has been extended several times. When its life does come to an end, it will crash into Venus's surface.
We will learn more about the whole evolution of the planets in the solar system, the inner planets of the solar system, including the Earth, from the start after the formation and also until the future of maybe millions of years from now, by better understanding how planets work all together in their interaction with the Sun and in their internal evolution.
What comes next is the interesting thing. At the moment, there are no other probes planned to Venus. When Venus Express ends its mission in 2015 or 2016, we're then going to be in a period where we can't monitor and we won't be able to learn any more about Venus. And hopefully this is something that one of the major space agencies will pick up and we will get a mission in the next few years.
The adventure will continue for years yet. But why this incessant quest, this desire to discover?
The ants and the butterflies, however they are beautiful, the butterfly, they don't ask themselves any questions about their origin, about the universe, about formation of stars and planets. We have all these questions because we are human beings, and it is in our nature to explore as human beings.